Hello everyone, my name is Sachin Agarwal and I'm working as a solutions architect at Nirmata. So today we will discuss how Nirmata and Opencost can deliver proactive resource and cost optimization for the Kubernetes environment at scale. As a background, Kibana provides a scalable way of continuously monitoring and validating the resource against the policies defined. And Opencost provides a real-time cost associated with the resources running on the cloud or on-prem solutions. So before we jump on to the demo, let's just look into the challenges that we are aiming to address here, right? So one of the challenges that the continuous right sizing of the resource allocation for the application. So this is the biggest challenge which most of the teams are facing. The other challenge is how they can reduce the inefficiency of resources due to the dynamic nature of Kubernetes environment. The third challenge is understanding the cost implications of over-provisioning and how it can be addressed. And the fourth and last challenge is defining the cost policies for the teams and doing the budgetings for the teams. So together with Nirmata, we provide following benefits where we help in continuously right-sizing the application resources via VPA recommendations. Second, we help in reducing the overall inefficiency of the resource allocations across the workloads and hence providing the cost benefits. And the third thing is providing the budget-based policies across different teams for better tracking. So today we plan to show the following demo where how we integrate with OpenCost can help you in understanding the cost associated with the over-provisioning of resources and how it can be reduced using the resource recommendations which are provided by VP Recommender. So for today's demo, we have actually deployed OpenCost for cost analysis. Prometheus is there for storing the cost data. Metric server is there for providing the resource utilization, which will be used by VP Recommender for providing the recommendations for optimal resource utilization, and Nirmata Control Hub for enforcing the policies. So let's jump to the demo, and I have actually created a Kubernetes cluster in AWS. So there's a EKS cluster running. So if I just do get nodes, so you'll see that there are a couple of worker nodes running here, right? And get NS. We also have the namespaces running here. So for this demo purpose, I have created one namespace called banking app under which there is a application running called payment. So get deployment banking app. So this is the payment app which is running, and currently it is running with 3 replicas. And on this particular terminal, you will see that the recommended values by VPA recommender, which is 15 millicores and 33 megs of RAM. So this data is in bytes. And if we just jump to the policy also, which is deployed. So currently I have deployed 2 policies here. So you get cpol. So you'll see that there are 2 policies called check resource and generate VPA. Generate VPA will be used for generating the resource, VPA configurations for any deployment that you are deploying in Kubernetes, and check resource is the policy which will actually take the values from VPA recommender and raise a violation against your resources for optimal usage. And this is the policy which is actually doing this validation. And as you can see here, we are doing an external API call to get the cost data from Opencost. And based on that, we are actually converting the data cost-wise, like how much you are going to save if you change your configurations to the optimal values. So let's see, currently I have deployed this application. So, okay, edit. deployment banking app. And currently I have set the CPU value to 1200 millicore and memory to 1500 mix. And this is way above the optimal values which were provided by VPA. So already this application is generating certain violations. So if we just quickly see what all violations are there. So I'm just querying the policy reports and grepping all the field rules. And as you can see here, it is giving us a message called validation failure, over provisioned resource, reduce CPU request from 1200 millicore to 15 millicore. The total cost savings on CPU would be $7.09 per month. This is pretty small number currently because it's very small setup and not much cost is actually going to be incurred. But as you can go beyond different applications, definitely this will be a significant value, right? Similarly, it is also raising a violation for the memory, right? And I have also registered this cluster with the Nirmata Control Hub, so we can actually see all this data on Nirmata Control Hub also. And as you can see here under the category called resource optimization, you will see that there are two violations that is being raised. And if I just click inside this and if I go to my application called payment, here you will see that it is actually giving the data which was provided on terminal in the Nirmata Controller Hub also, saying that you have over provisioned your CPU and memory. And this is the cost saving that you will be incurring, right? And I have also exposed the Opencost UI, which will give you the cost uh, expenditure up at the date range of 7 days, and you can actually break it down to even more levels like containers, pods, stateful sets, and all, right? And this is the data which it gives. And all these datas are coming through an API call from AWS, which is AWS Cost Explorer API. So OpenCost is actually referring to that data for cost associations. So this is a small demo. I hope you like this session. Thank you so much.